taking a look at the product and quotient rule. And these are just rules that help us solve more complicated derivative problems. So let's first take a look at the product rule, which basically states is that if we have the derivative of some product between two functions of x, this is going to be equal to f of x times g prime of x plus f prime of x times g of x. So, or you can just think to yourself the first times the derivative of the second plus the derivative of the first times the second. And why don't we take a look at an example of this product rule in action. So if we have the function f of x is equal to 4x squared cosine of x. And so this is clearly a product rule because we have two functions of x multiplied together, 4x squared times cosine of x. So if we apply the product rule, this will be f of x and this will be g of x. And so we just follow the formula. And if we have f of x, then we leave the 4x squared, and then we multiply by the derivative of g of x, which would be negative sine of x. And then we're going to go ahead and add the derivative of the first, which will be 8x times the second function g of x, cosine of x. And there we have it. That's our answer. So we can simplify it a little bit. We can do minus 4x squared sine of x plus 8x cosine of x. That's our final answer. Yeah. You can also factor out the you can factor out like 4x, for example, if you wanted to, but it's really not necessary as long as you get the correct answer. That's really all that matters. So why don't we do one more example of this just to help us out a little bit, understand this concept even more. So we have y is equal to secant x times tangent x. So product rule, we see that we have secant x multiplied times tangent x. So if we take the derivative, oh, sorry, I should have put that this is the derivative up here. My bad. So if we do dy dx and we follow our formula, this will be f of x, this is g of x. So if we do our formula, then we'll do secant x times the derivative of tangent x, which is secant squared x. And then we're going to go ahead and add the derivative of the first function. So the derivative of secant is secant x tangent x, and then we leave tangent x at the end. And so you can go through and simplify this. This would be secant cubed x plus secant x tangent squared x. And then you can do some more processing and factor out secant x, or you can even change, you can rewrite the secant cubed x as 1 over cosine cubed x and do some manipulation with all that. But what we're focused on in this video is just getting the correct answer and getting ourselves familiar with the product and quotient rule. So we'll just leave our answer like that. Okay, I think that is sufficient for the product rule. Why don't we take a look at the quotient rule? Okay, so what the quotient rule states is if we take the derivative of some function of x divided by another function of x, so we're dealing with some division here, this is going to be equal to g of x times f prime of x minus f of x times g prime of x all over g of x squared. Now, this can be a little bit complicated to memorize, so there is a little memory hook that people have come up with, and that's just if we do the derivative, if we think about these functions in terms of high and low, so the top numerator and the bottom denominator, and well, the little memory hook is pretty simple to remember. It's just low d high minus high d below all over low squared. So that's kind of like the memory hook, and these two match up. This one's just a little bit easier to memorize. So let's do an example involving the quotient rule. So we have g of x. So we have g of x is equal to sine of x over cosine of x. And this is interesting because some of you are probably thinking, well, you can just simplify this to be tangent x. And we know the derivative of tangent x is secant squared x. But let's apply the quotient rule and see if we get the same thing. So we're going to do low. So g prime of x is equal to low times d high minus high sine of x times the derivative of the bottom minus sine of x, all divided by the bottom squared. So simplifying this a little bit, we have cosine squared x plus sine squared x over cosine squared x. And from our trig identities, we know that cosine squared x plus sine squared x is equal to 1 over cosine squared x. And there is our verification that the derivative of tangent x is secant squared x. And why don't we do one more example? We'll just go ahead and it's a little bit more of a complicated, not complicated, but more involved problem. So we have y is equal to 3x plus 4 over x squared minus 2. And if we want to take the derivative, we'll just do our little memory hook. So we have low times the derivative of the top, which would just be 3, minus high, 3x plus 4 times the derivative of the bottom, which would be 2x. And then we go ahead and just set that all over low squared. So x squared minus 2 squared. Okay, so some simplification. Why don't we distribute out this 3 here? So we have 3x squared minus 6, and then also do some distribution here minus the quantity 6x squared plus 8x. Yep. Then we'll just keep the bottom the same for now. And then let's go ahead and distribute our minus sign right here. Keep the bottom. Oh, my pen stopped working. There we go. And then if we look at the top, this is going to be equal to minus 3x squared minus 8x minus 6. And then we can just leave the bottom as x squared minus 2 squared, and that would be our final answer.